As Chris has said, my name is Blake Hagedorn. I'm with the Little River Drainage District. We are out of southeast Missouri, about 120 miles south of St. Louis. Um, we, I've been with the company for roughly 4 years, 2 years as an intern and 2 years full time. I'm a civil engineer for the company, and I handle all the GIS operations that happen within inside the company. So before we can kind of talk about where we are and where we've come from with the GIS, I have to give a little bit of history on the company because it is such a unique situation. We are such a unique company. In the early 1800s, Southeast Missouri was covered in 95% trees and water, um, due to the fact that we lie right on the banks of the Mississippi River. So when the Mississippi River would get up in the 1800s, it would flood out this area. With this area being such a flat area, it had no way for the water to drain. So the federal government tried to drain this swamp for many years and had many multiple failures. So they passed the Swamp Act of 1850, which reverted the title from federally owned ground to the state-owned ground and then to the counties, so the counties could then turn around and sell it. Which then brought in the investors. The timber investors came in the late 1800s and they started to buy up the ground, and they bought up these large swaths of ground, like 500 or 50,000 acres to 100,000 acres at a time. They came in here to just strictly harvest the timber because we had very rich timber that was worth a lot of money back in the day with the oak and the cypress and gum. And once all the timber was harvested, like you see in the picture in the background, there was no more timber growing in the area. So these guys paid less than $1 per acre for the ground, and now they're paying roughly $2 an acre in taxes. So with that, they knew that they needed to do something with the ground, make it productive so that they could get a return on their investment. So essentially, that's when Little River was born. The district was formed in 1907 with the leadership of 5 engineers. Some of these engineers were on the same team that helped design and plan the Panama Canal. After 6 years of planning, designing, surveying, there was a plan in place for the construction to start. As you guys can kind of imagine, that that was in 1907. No technology, no GIS, no aerial photos, no drones, no survey equipment like we have now. It was all chains, and it was a rough way to go. So like I said, in 1913, the construction was underway, and for 13 years later, and by 1926, the Little River Drainage District was in full function. They had moved over 66 million cubic yards of dirt in 13 years, which is actually more than the making of the Panama Canal. So like I said, we have a very unique system within the United States that's not really talked about. And it's very unique to us, and it's very beneficial to us because for the state of Missouri, a third of the GDP actually comes from this small section in the Boot Heel, Missouri. The district is made up of about 1,000 miles of ditches and 300 miles of levees. Our district size is 550,000 acres, but we drain a total of 2 million acres. Today, we're still maintaining and managing all the ditches and levees. It's a full-time job, something we have to do day in and day out. Our operators work on average 50 to 60 hours a week. We have roughly 35 operators out in the field right now, and we have about 50 to 60 pieces of equipment, just depending on the time. We have everything from excavators, tractors, dozers, to whatever you can think of when it comes to heavy equipment. In 09 was before I came on, and this is kind of where we started getting into where we started to have a problem. Was in 09 we only had 8 pieces of equipment. By 2021, we've more than quadrupled that, like I said, 50 to 60 pieces of equipment. So with the large expansion came the challenges of having all the equipment to deal with, having the employees to manage and operate. And with one of those challenges was something that I saw early on coming in 4 years ago, was how we tracked and managed our fuel. In 2009, we went through roughly 30,000 gallons of fuel. In 2020, we went through 275,000 gallons of fuel. Back in 09, we had about 1,000 gallons of fuel storage on site. Today, we have just over 60,000 gallons of fuel storage on site. The way that we used to manage it just 6 months ago was pen and paper. Everything was done when a guy would check out fuel. If I was checking out fuel, I would say, my name is Blake Hagedorn. I'm signing 560 gallons to a machine 336A, whatever that machine was numbered. And that's how we'd sign off on it. And then if they signed off in if they wrote that out in January, I wouldn't get the reports till the 1st of February. And then when I get the reports, I would have to input them in some sort of Excel or whatever else would work to be able to balance everything out. So if I saw that there would be a problem in the fuel, then I wouldn't know anything till probably mid-February. So that's when I started to get involved with Esri, and we'd already been using some of their things in the past, and then I got in with Eric and Jay, and we started talking and having some ideas together, and we were able to use Survey 123 as a collection site, and then have a dashboard in the background that would manage all everything and pretty much put it out there for us to be able to visually see. With doing that, though, I told Eric, we have a lot of guys that are not technology savvy, a lot of guys with flip phones, and, not a lot of smartphones going around the shop. So we needed this to be as simple and easy as possible. And we have 2 locations. So we have a South District location and a North District location. We have an iPad set up at each shop that is set up in a kiosk mode, so they can only have this survey up at once. So they actually can't get out of it, and the survey stays on there all the time. So we were able to come up with a very easy, user-friendly system, and I'm going to show you guys that right now. This is exactly what it looks like for the guys in the shop. Every time when they go get the fuel, they have to turn the fuel on right next to the iPad, and then they simply select what kind of fuel or what oil or whatever else they might be taking out. Now I'll kind of take you through this. So these are all of our guys on the North District end. And so if I want to select my name, it automatically will pop in the date. And then I go to the fuel. Now we track from everything from dyed diesel, road diesel, gas, DEF, engine oil, hydraulic oil, drivetrain grease, antifreeze, even down to window wash. Anything that we buy in bulk, we have to keep track of. That way we can have an accurate number for how much that machine costs us every month, because these are all costs to the machine. So if I want to select dyed diesel because I'm going to check it out to a machine that month, the only things that will pop up in the equipment list is everything that will take dyed diesel. So you can see here's some of our equipment that'll pop up, along with certain things like DEF. Not all of our equipment takes DEF. If you don't know what DEF is, it's diesel exhaust fluid. It's a new thing that the government has mandated that you must have on diesel equipment, and it goes for diesel pickup trucks and everything else. So everything that takes DEF is in this list. So say I want to check out fuel to my truck. So we have road diesel, and I go down here to Blake's F-150, and I'm going to check out 30 gallons. So I hit submit and submit it in. And all of my guys have to do to submit another, if they were going to check out dyed diesel later that day, they just hit here and it pops back up. So that was very simple, very easy, and it's been very easy for the guys to get used to. There wasn't a whole lot of coaching. It explains everything, and we have not had anybody have any issues with it. The next part was for everything in the office. We needed to be able to break down this data quickly, efficiently, and be able to assign a cost per machine. Again, working with Eric, we were able to do this. I'll kind of show you guys what the dashboard actually looks like back here on the back end. So this is what our dashboard looks like. This is from the beginning of when we started. I think we implemented it sometime in July. So it shows, we've gone through about $115,000 of fuel, $95,000 of dyed diesel, which is the majority of what we go through. 60,000 gallons. And as you can see, kind of take a look around, see what else is there. Something also that we're able to do is go through, and so if these are the equipment that have been checked out for the fuel. If I want to click on this 336A, it'll show me, exactly how much fuel, how much it's cost us to run that machine with fuel, depth, grease, all the etc. from, the start date of this in July to now. And if I wanted to pinpoint a range, so let's just say today is the 11th, and it'll actually show me what I submitted. So that's under my vehicles tab. So there it shows me, there's my pickup truck, and it costs $74. So if we go and want to see everything in the beginning of the month of January, so there we can see all the equipment. Click out of that. Sign up on that. There it is. So there we can see all what the equipment cost was for January. So I can go through here and see this machine cost that much. It used that many gallons of diesel, that many gallons of depth, this many tubes of grease, and so on. So that way we're accurately tracking this system. Beforehand, when we would buy a pallet of grease or a pallet of oil, we would just have to say, well, there's 50 boxes of grease and we have 50 pieces of equipment, and divvy that up. That's one box of grease, and that's how we would have to track it. Now we actually have an accurate system to track with. So the fuel has been a huge help for us. We have been able to cut our time in half. I'm able to come in here and give a report to our accountant, and she's able to go through and look at everything and be able to quickly associate a number with that machine so that we can have our reports done for the month. Another thing that we've been able to do is do the job completion dashboards, which were something I didn't even think about until we just started this project that we started in about September. Eric helped me set this up, and since we are a drainage district, we are constantly moving. It's a little bit different than any kind of other construction site, but right now we're in a project of digging 430 miles of ditches. So with that, we're constantly tracking our machines to see where we are with it and how things are coming along. So as you can see here, this will show exactly where we are. So we have 430 miles to do. We're about 30% complete. We've completed 126 miles. And then on top of that, I'm able to break it down by district. The green is showing where we are, the green and the red is showing what we have to complete. So I know my North District's got 52 miles done, and they got 197 miles total to do. So they're about 26% complete. My South District's got 77 miles done, and they're 33% complete. So these are just major benefits to us to not having to go through and hand calculate all this stuff. I'm able to just say that machine's right here at this particular time, and it automatically calculates everything in. So then once a month at the board meetings, we can turn in a nice looking report that shows where our machines are at, but also what they've got done, how much they got done prior to last month. Why did they not get as much done this month? Well, we might be able to explain, well, okay, we had rain, we had snow, we had all these other weather that caused this to be slower. And then we also get to show how fast they're moving in the summer months and stuff like that. And in the future, we're currently working with Jay and a couple other engineers there at Esri, working on putting together a tax book, since that is one of the ways that we are funded is through the taxes through the landowners. We're putting together a tax book to do the parcels and be able to run and see how much each county we collect in each county and who owes, and be able to highlight each parcel to see who is paid and who is not paid. And then also using Asset Manager, we do have roughly around 4,500 acres of farm ground, being able to see what piece of farm ground brought in what yield, what was it planted in, when was it planted in this, who farmed it, and all those other things. So we're always looking for new ways to save us time, save us money, and be more efficient within the office. Because if we're efficient in here, we know our guys out in the field will be more efficient. And we thank Eric and everybody else in the GIS team for helping us along the way, and we look forward to a lot of other future projects.
So hi, my name is Patrice Moore. I'm the GIS supervisor at Beaufort-Jasper Water and Sewer Authority. I've been in this role for nearly 6 years. I've worked in location intelligence for 20 years, doing all sorts of cool stuff from natural resource mapping and site selection and analysis to feature extraction from satellite imagery to maintaining municipal and public works data and systems. So I am thrilled to be here today to share BJWSA's GIS evolution from roadmap to implementation with all of you. This is a real treat for me. I'm very proud of the work that we have done with our Esri team, and I hope that it inspires others who may be experiencing the same challenges we faced along the way. And it's not advancing. Okay, there we go. So a little bit about BJWSA. Beaufort-Jasper Water and Sewer Authority is a public nonprofit corporation handling water and wastewater operations in Beaufort and Jasper counties in South Carolina. So BJWSA treats an average of 20 million gallons of water for consumption and 9 million gallons of wastewater daily. We have 2 water treatment plants and 8 wastewater treatment plants. And we have about 600 lift stations across our topographically low and flat coastal plain service area. So we have about 55,000 water customers. We wholesale water to several neighbors, including Hilton Head Island. And we manage water and wastewater for Marine Corps Air Station Beaufort and Marine Corps Recruit Depot Paris Island. So all told, we serve more than 150,000 low country residents with drinking water. Now for a quick history of GIS at BJWSA. So as the tale goes, in 2004, an unsuspecting employee was pulled from another department and was told to begin cataloging as-built. So that was the start of BJWSA GIS. For the next decade, investment in GIS was low. So we had a department of 2 and generally only staffed with 1. And in early 2014, with no supervisor on staff at the time, the entry-level GIS specialist had wrapped up her term by upgrading ArcGIS from 10.1 to 10.2. I never met her, but I want to give a shout out to her pioneering spirit. So good job. When I arrived in mid-2015, the department had been completely unstaffed for nearly a year and a half. So we had work to do, to put it mildly. We had work to do with data, systems, and interdepartmental relationships. But this is a story of how determination leads to success. So in 2016, we upgraded to 10.4.1. In 2020, we overhauled our GIS, bringing it to version 10.7.1 with portal implementation. We expanded our ArcGIS Online and made the transition from ArcGIS Desktop to Pro. So this transformation was made possible by Esri Technical Services, the support of our amazing staff, and the onboarding of a new Deputy General Manager who knew the value of a good GIS. So up until 2016, GIS was an afterthought. It wasn't highly integrated with decision-making at the top levels of management. We had a web map which showed assets in several operational layers, but not a lot of opportunity for user analysis or growth. And all of that was about to change. So 2016 was a good year. It was the year that a new Deputy GM of Technical Services was hired, and he came to us from a very large metropolitan water agency. He introduced asset management as an executive goal. So finally, GIS had a champion in the C-suite, and it absolutely shined a white hot spotlight on improvements that were needed in the GIS and in our CMMS. So now that BJWSA began to transition from reactive-based maintenance to preventative maintenance, suddenly we had the support of the executive team and the focus of the board of directors to charge forward with enhancing and expanding our GIS. And so anyone who has heard the term asset management has also heard the term data gaps. So the chronic lack of investment in GIS led to all sorts of suffering, including very large data gaps. We had data gaps in attribution and within the network itself. We had a backlog of over 500 engineering projects not yet added to the GIS. And there were high stacks of paper showing penciled in map updates, and there were field ops personnel with low morale after they had been kind of left to limp along with little to no mapping support. And this was a big problem. So we needed them we needed their help to get crucial KPIs like material and size into the water and sewer asset layers. So we also had some hurdles to overcome with our CMMS. Our work orders were not linked to assets. How the work orders were completed varied from field team to field team, as well as the amount of information that they collected during the course of their work. Further, we needed to improve our web map availability to our field workers, like offering offline maps and such. And so we had a lot of work to do, and we knew it, but we now had the executive support that was crucial to our success. So I began the hard work of building trust and establishing a teamwork-focused partnership with engineering, field ops, and customer care in order to begin. So in 2017, with data gaps and asset management and upgrades and mobile GIS on my mind, I attended the Esri Public Sector UC in Florida, and I sat in on one of David Crosby's sessions entitled Get a Second Opinion with Esri's Health Check. And as I sat listening to his presentation on what Esri's best management practices were at present, and knowing what we had back at the office, these exclamation points and light bulbs were firing off in my head. And so I approached David after the session and said, wow, this is something we really need. Our GIS was established over a decade ago, and we're essentially still running the same system. What should I do for next steps? And David is such a personable fellow. He was truly excited to answer my questions and point me in the right direction. So that began discussions with Robert Rodriguez, our account manager at the time, and discussions with our new Pro GIS DGM to help me secure the funding for an enterprise license agreement and an Esri GIS assessment and health check. So in October 2018, we were able to move ahead with the Esri, coming on site for our health check and assessment. And this effort produced a document that we could refer back to, which showed the present capability, some opportunities for quick wins, and outlined system reliability goals. So now we had a plan. We had an industry best practice plan. So that was very exciting. And this could be used to negotiate and secure funding and support for the next step that we took with Esri. And that was the production of a GIS roadmap and implementation of the assessment findings. So here we were now in 2020, after years of effort, all of the begging for funding, so many meetings, interdepartmental bridge building. Here we were finally moving ahead with the ArcGIS upgrade to 10.7.1. The server reconfiguration, the portal implementation, the ArcGIS Online expansion, and the production of all the cool apps and solutions that come with it. So just a wonderful time for us at Beaufort-Jasper. And this is our amazing team that helped us achieve these goals. We truly had an all-star team from Esri, from the health check to the implementation. This team was with us the entire time. Robert was fantastic with keeping us organized and on track, and he assisted me with our hydrant inspection solution as well. We were incredibly lucky in having Catherine Browning assist. She brings a wealth of knowledge on database administration. She's savvy on all the fabulous solutions that Esri Water produces. And she cherry-picked our data review team and brought in Michelle Johnson on data reviewer and Tiffany Weintraub on the attribute assistant. So shout out to all these fabulous women in tech. And to have David come in for our system side was just, wow, we were lucky ducks. He is a hot commodity at Esri, as I am told every time I mention his name. I love that he was actually the inspiration for spurring all of this progress, and that he himself would actually help us achieve this. It was just enormously special. Will Walter helped me a great deal with the WebGIS support. He had enormous patience with me. He was always willing to jump on a call to troubleshoot or walk me through setting up a new app or solution. Just an incredible team at Esri, so thank you so much. Internally, I was also incredibly fortunate to have the best IT support anyone could hope for. We have an amazing IT team here at BJWSA, and Philip McCright is not only extremely intelligent and knowledgeable in his craft, but he's also very funny. So the Esri team just loved him, and having him assist was icing on the cake for me. And if you have any questions on the technology we use and systems engineering, that sort of detail, I can certainly get you in touch with Philip, and you can get a taste of his sense of humor firsthand and loads of techie details on our GIS system. He is also in the audience, so if you have any questions, maybe he can hop on and help you out. So the path to the GIS roadmap. So again, in 2018, Esri was on site for 3 days. The first day was performing a SWOT analysis, so we were getting to know our strengths and weaknesses and opportunities and threats. And this was as perceived by dozens of people from various departments throughout the organization. So we truly gathered the input and goals of the entire company as it related to GIS. We had key staff from IT, treatment operations, engineering, field operations, customer care. We had all of the administrative coordinators come into these interviews, and it was really revealing and empowering for those folks to actually have their voices be heard and documented, and actually have some work be put into achieving a resolution to their needs. So this was a fantastic experience in and of itself. And so the next 2 days, Catherine and David reviewed our workflows, our editing maps, our web maps. David partnered up with IT to review our servers and services, their performance, our mobile mapping use and opportunities. And so all of these meetings and discussions boiled down to our immediate business needs and an assessment of the current state of BJWSA GIS and the path forward for Esri's best management practices for the water industry. And the list you see here were the most important takeaways from the health check. So we definitely wanted to improve maintenance of GIS information. We needed to eliminate some of the redundancy in other business systems, but also we wanted to improve implementation and integration with GIS to other business systems. We definitely wanted to improve the availability and discovery of and sharing of GIS information. That would also lead to enhancing analysis and improving decision making. And we wanted to improve our access for the public as well. Now, as to the assessment of our existing deployment, our system was pretty much designed as depicted in this diagram, where 2 machines available to process requests and give some level of redundancy in the system at the GIS tier. However, during the assessment, David found that our config store and server directories were installed on one of these GIS server machines. And what that meant was, if that machine happened to be the one to go down, the other would be unavailable as well. So, surprise, we actually had no redundancy built in. So it was Esri's recommendation that the config store and server directories should reside on an independent, highly available file server. We also had only anonymous access to our web map portal. So Esri's recommendation there was that we leverage our Active Directory environment to provide users and groups to ArcGIS server. And then in the future, after our portal implementation, we would leverage the security features available within ArcGIS Enterprise to manage access. And that would also be integrated with our Active Directory identity store. Specifications. So here we have some specifications of the server technology, and this figure here to the left showed what we were using, and underneath is what Esri recommended for our new technology. The figure to the right shows the current and proposed CPU performance, and this red line here is Esri's baseline. So we weren't too terrible, but it could definitely be improved. David proposed some new technology for a more contemporary spec per core rating in the upper 40s. David's explorations produced a lot of information in our health check and assessment report. He looked at our network performance as compared to industry standard SLAs. And what I have here are Esri's recommendations. But all in all, we didn't score too badly, which was a nice surprise. Our network administrator, AJ Gumatau, did a great job and worked closely with David to dig into all that for us. And the reporting was quite extensive. And then Catherine went into the geodatabase review. So she was looking at our maintenance practices, how performative our database was, where it needed tuning, all of these things. So she was quite an amazing asset to us because we don't have a DBA on staff. So maintenance was badly needed. So Catherine produced quite a number of recommendations. We had some interesting surprises again. So we had upgraded to 10.4.1 in-house with no assistance from Esri years prior. But what failed to be upgraded were our geodatabases. So they were still sitting at the 10.2 level. And so they needed to be upgraded to 10.4 and then to 10.6.1. And at the time that these geodatabase recommendations were written, 10.6.1 was the highest or the latest version. But by the time we actually implemented these, we were looking at 10.7.1. She also recommended that we move from SQL Server 2012 to 2016. We were storing 2 different geometry types. So the older geometry type, the recommendation there was to migrate from SDE to STO geometry. And Catherine also helped us set up automated compressed scripts, which would also rebuild indices to improve performance. She found that our log files were enormous, so that was also impacting performance. And she really set us on the right path for database maintenance, and that was a huge benefit of this project. Now, from their 3 days on site and the SWOT analysis with the organization and the assessment of the existing GIS infrastructure, Catherine and David defined some big picture goals for BJWSA, and that included following and continuing to expand a WebGIS pattern to provide a wider range of internal capabilities for our WebGIS users, to provide more self-service mapping on ArcGIS Enterprise or ArcGIS Online, and that would reduce the requests for creation of maps. We did not have a staging environment, so that was an opportunity for improvement there. We needed to implement systems that were deployed appropriately, so think of our redundancy fail there, and follow recommended best practices for workload separation and environment isolation. So that carried us into 2019, gave us some food for thought, some actionable, immediate improvements in terms of geodatabase maintenance and workflows. So meanwhile, I secured the funding for the implementation of the Esri roadmap and upgrade. So fast forward to 2020, where we have our contract in place. We're moving along with the planning pieces. We have the test system and configuration and upgrade scheduled for late March, and then COVID. So the first week of March, BJWSA went remote for all staff that were able to. So we shifted the plan from Esri on site to all work being done remotely. And strangely, this was a benefit to the project. It gave me a solid period of time where we had limited distractions and to really dig in deep with Esri and get a lot accomplished. But I did certainly miss seeing Catherine and David in person. So broadly, this is the list of support pieces required to execute on the roadmap recommendations. The first leg was to be planning. So we had migration planning, implementation planning, capacity planning. We had allowances for geodatabase migration and upgrade on both of the staging and the production environments. We had a data quality assessment in there to help us prepare to move to the utility network in the future. And we had a whole lot of hours in there for WebGIS support, which was absolutely fantastic. So here's the breakdown of Esri's level of effort to help us pull off all of these goals. Now, this was a specific plan tailored to BJWSA's needs, so keep in mind that costs will vary based on the needs of your organization. But as you can see, we had a good bit of time devoted to planning, about a week and a half, and that was followed by about the same to set up the test or staging environment. And in between the staging and production implementation, we dug into some of the WebGIS support hours. Excuse me. So this was brand new software for me. I had some experience with AGOL, but Portal was brand new. All of this was a whole lot to take up in the space of 4 months. And so once the test system was set up, I now had the opportunity to work with Esri's Will Walter on the WebGIS offerings and really cut my teeth on using the web app builder, developing dashboards and all that good stuff on our test environment. And then David and Catherine came back on with us in June to move forward with creating our production environment and basically repeating the process that we just went through for the upgrades, but on the production side. So once that was complete, we spent more time on additional WebGIS support for a whole host of solutions and dashboards. So now we have Esri's recommended server configuration in place with all the components installed correctly and functioning as intended. And we have an identical setup for our test environment. So I just covered a lot of work with the system upgrades and implementation, but here is even more cool stuff accomplished during the course of this project as it relates to data quality. So Esri performed a utility network data readiness check, which included a data reviewer knowledge share, where they set up a ton of data quality checks for me with batch jobs and a report on our data readiness. So I came out of this armed with ready to go tools that I could directly employ to improve our network. Another huge benefit to us was the attribute assistant knowledge share. It came with about 30 configured rules to automate and improve our editing workflows. And I have since expanded that to about 160 rules. It's my favorite toy. It's done an amazing job of filling in those data gaps with a click of a button. So for example, we had diameters of valves, but not on the pipe. And so these rules populated the diameter based on the valve diameter and vice versa, and the same for construction dates. The WebGIS support was absolutely phenomenal. I think I ran poor Will ragged on these because that's the cool part, right? That's the fun stuff. We were able to set up water and sewer asset map viewers, the hydrant inspection solution, the utility isolation trace solution, and we developed a service area lookup app. And these solutions were directed by the organization's needs captured from the SWOT analysis back in 2018. And here's some screenshots of our cool apps. So we've got the service area lookup here on the top left and the valve exercising solution. And this also comes with a workforce component, and they were developed during the implementation. And so this is instant return on investment, right? As soon as everyone sees these hot dashboards and apps, they love it and they want more. Our water quality dashboard that you can see here in the top right, this was born of an emergency that occurred in April in the midst of our implementation project. So we had this horrendous water quality event that occurred after a construction project tied a very large main into another large main and sent sediment downstream to our customers. And it happened on a Friday afternoon, of course. So we had calls pouring in, overwhelming our call center, and management had no way to quickly determine the problem area. We had all these emails, we had spreadsheets with addresses, and we had no way to visually see what was going on and who was affected. So Will helped me develop the Survey 123 app here that you see, and this is the water quality issue reporter, where our customer care staff can quickly report and map water quality complaints. And this service feeds the water quality issue dashboard and gave management immediately actionable information to quickly see where problems were occurring, and I also isolate some chronic areas for further investigation. They loved it. And of course, this was all being done in the time of COVID. So I had heard through the grapevine that one of our executive staff was really in love with the Johns Hopkins COVID-19 dashboard. And I also had been glued to it, probably checking it 3 times a day at least. So I styled our water quality issue dashboard in the same manner as the Johns Hopkins to hopefully reel them in a little bit more. So it worked. As soon as they saw the dashboard and how efficiently the reporter app performed, they wanted to see more. So they requested the low pressure report dashboard here, and that's the one you see in the lower section. And they also requested the lead service inventory solution be set up. So we are starting on that project here shortly. So the project was a great success, and Esri did a fantastic job for us over the course of this 4-year story. And I would recommend this route for anyone who is able to take advantage of these professional services. So thank you, Esri, for the amazing talent and direction during our journey to enhance location intelligence at BJWSA.
Hello, everyone, and thank you for joining us today. My name is Sara Mendiola, and with me is Rebecca Segura. We're both GIS analysts at the San Antonio River Authority, and today we're going to be talking about updating water quality data using FME automation. Next slide. Before I jump into that, I want to say a little bit about our organization. Here we have a map of our jurisdiction. It's the San Antonio River Basin, composed of several watersheds, and our 4-county jurisdiction, north to south being Bexar County, Wilson, Karnes, and Goliad. Lastly, we have our namesake, the San Antonio River itself, starting in the heart of San Antonio, making its way south 240 miles to the Gulf Coast. Our organization is committed to safe, clean, and enjoyable creeks and rivers. That's our mission statement, and you could read it at the bottom of the slide there. And we have several departments, one of which, the Environmental Sciences Department, speaks mainly towards the clean aspect of this mission statement. They're composed of many team members, such as aquatic biologists, water quality scientists, stormwater scientists, and they understand the fact that natural and man-made activities do have an impact on our watershed. So they do their best to monitor, mitigate, and improve the health of our river. They do that by taking samples at monitoring stations across our basin, and we use our in-house regional environmental laboratory, which is TCEQ accredited. For our non-Texas natives, TCEQ stands for the Texas Commission on Environmental Quality. And I mention them just because they're a major partner of ours and we report a lot of our findings to them. So being the GIS liaison for this department, we collaborated together to communicate some of the parameters that they get out of their water quality sampling, one of which is E. coli. And they collect a lot of information about their water quality samples, such as nitrate, total phosphorus. But they wanted to communicate E. coli specifically so we can communicate to our public the contact recreation status of these monitoring stations. So I'm going to pull up the dashboard, and I want to encourage everyone to visit our website, sariverauthority.org, and on the Maps Data tab, you can find all our applications and even the bacteria dashboard. Let me go ahead and pull that up. All right, this should look familiar to you. It's our basin, as well as the monitoring stations located all throughout the basin. They're color-coded to match the contact recreation status, which are standards set by TCEQ. I'm going to go ahead and zoom into one station in particular. And unfortunately, I can't cover every aspect of this dashboard, which is why even more reason to go visit our website and pull it up yourself. But I am going to click on this San Pedro Creek Culture Park station to enable the pop-up and show you the information. We have station ID, description, geomean, most recent, max E. coli, as well as photos of upstream and downstream from the station. I want to bring your attention to this hyperlink here. It's a link to the current conditions for this site. And this is a graph that shows current conditions. And what's most important about this graph is that it shows rainfall. And there's only 7 stations in this dashboard that have that link. And I'm bringing this to your attention because it's an element within Rebecca's FME workflow. All right, so we have E. coli that we're showing here, and you're probably wondering what's E. coli. And E. coli is bacteria, and it's bacteria from fecal matter. We find this in our water bodies after stormwater events because the stormwater runoff makes its way into the water bodies. And so we like to report our findings about that and try to notify the public of when it spikes, things of that nature. Another thing I want to point out is that, okay, so we have the monitoring stations layer shown here, and then we also have this results over time layer. It's essentially the same layer, just unfiltered. So to calculate geomean, which is how we determine the contact recreation status, we have to use historical E. coli results. And so you use 18 E. coli results over the past 5 years to calculate the geomean, and we house all that data within this layer at the bottom. And it's connected to this graph, and we use like a binary system like 0 and 1 to just show like a filtered view. So instead of clicking at a station and getting like 18 records, you're just getting 1. And I'm noting that because it's important in Rebecca's portion of this presentation. All right, I'm gonna go ahead and minimize that and jump back to the presentation. The data that we use for the monitoring station comes from an SQL view, and it's about like 4,000 records, right? And it's kind of temporal in nature. After every stormwater rainfall event, we have our scientists going out into the field collecting samples and then entering that into the SQL server database. It's originally the workflow required a lot of manual updating. So let me jump to this workflow here. I would go into the SQL server, pull in the view into ArcMap, and then overwrite the existing bacteria feature service that's on our Arc Online platform. When we first created this, we were using ArcMap at the time. Now we've converted to Pro, we've modernized. So yeah, with the purchase of our FME software, we were able to completely automate the process. And tackle these points that you're seeing on this slide, which is to get rid of the manual update happening every month, making sure that there's formal backups, there's retention, and then that there's change detection. Here we're looking at a screenshot of the monitoring station's layer attribute table. I've outlined some fields in red, which are important for the pop-up and important for Rebecca's FME workflow. So we have station ID, which sort of connects everything, is end date, which is that 01 filter I told you about, as well as the URL and URL name field, which helps us embed those links in those 7 stations with the current conditions chart. All right, well, that kind of concludes my portion, and we're gonna jump over to Rebecca, but before we do that, we wanna get a feeler in the audience and see what your experience is with FME. Let's see, organizer, let's close poll. And Krista or Mariah will take care.
I've launched the poll. I've launched the poll, everyone. Sorry, I was talking over you there. I've launched the poll. You should be seeing it in your windows. How familiar are you with FME? A beginner, an expert? What's FME? Not familiar at all with this stuff. Don't worry, you're going to learn a little bit about it. I know Sara just wanted to launch the poll so that when Rebecca starts, we have a good idea of where you guys are at as an audience. So far, people love your poll. We've got 60% of our audience already responding. If the rest of you would just take a second to answer the question, how familiar are you with FME? It's greatly appreciated. Ladies, so far we have a bit of a 60-40 split, 61% what's FME, they're not sure. 3% are experts, so you have a few colleagues here that are using FME, and 36% classify themselves as beginners. I will close this poll.
Diverse group. Thanks, guys.
Yeah, exciting.
Okay, so based off of our FME poll that we just took, it looks like we have a variety of viewers. So I'm going to start off with a little introduction to FME. So this is FME desktop, and FME stands for Feature Manipulation Engine. It is an ETL tool, or an extract, transform, load tool. And what that essentially means is that you can read in your data and change it, and then export it and represent it differently. So to go into our workspace in particular, this is what our FME automation for the dashboard looks like. But before I dive into it, I want to point out 3 major components to building an FME workspace. The first one being your readers. The readers are where you read in your data, and FME supports different file formats that you can read in. So you can read Excel sheets, text files, shape files, and I think there's like 100+ file formats that you can read in. Next, we have our transformers, and these are the building blocks to your workflow in an FME workspace. So it helps you change your data, manipulate your data, and I'll go into a little more detail as I'm explaining our workspace. Finally, we have our writers, and this is when you have your final output of your data and how you want it, and then you can write out your data with these writers to your desired location. And also you can change it into a different file type, like an Excel sheet or a geodatabase. So I'm going to switch over to our actual working environment. So this was a screenshot of my last slide. And before I get into this, I want to acknowledge that Sara, myself, and our enterprise applications administrator, Nathan Davis, helped develop this, and it was a team effort. Okay, so going into each element, starting with our SQL view, whenever I click on this magnifying glass of the reader, it reflects what is in this SQL view. So we have all of our data over here on the left. And then we're going to go down to our AGOL bacteria dashboard reader, and this is reading the AGOL feature service. And as you notice, whenever I click on this magnifying glass, it adds that map spatial component. And this is a direct reflection of what is in AGOL. So you have your attribute table right here with all the data, and then our points for each station ID. Another important reader that we have is our master stations reader. So as you see the map over here, this is from AGOL, and when I switch there right here, there are a lot more points because these are our station IDs for every single station. So this comes into play whenever we are QA/QCing and making sure we are updating the station IDs. Before I go into the updating process, I want to show our backup process. So like I said, this is our AGOL feature service reader, and following this line that I just disconnected, that's okay. We have our backup process. And so the feature reader gets fed into our backup process, and it gets written to a file geodatabase. And previously, we didn't have this backup process. We were making copies of the data set before we make any changes. So now we have this automatically happening before we make any updates in case we ever need to restore it. And it's also being backed up for up to a year. We do have the option to change that, so we can change it to up to 2 years that we have our data backed up. So that's the cool thing about FME. You can really manipulate it and tell it what you want it to do. So I'm going to go into these transformers in particular. We have this attribute filter, and it is pulling out the nulls in our SQL view because we use a binary value system to indicate which is our most recent station ID. And so we wanted to replace these nulls with zeros, and with this attribute manager transformer, that is what we were able to do. So we had nulls in this is end date field, and now we have zeros. Moving on to the next process, we like to consider this the heart and soul to our workspace, because we are detecting the changes that occur from month to month. So we're using this feature merger, and the inputs are from the SQL view right here, and then the other input is the AGOL feature service. And we're comparing the data sets and identifying where we are going to need our updates and inserts. So like I said, it's detecting the changes that are occurring. So this output is going to be our new data set. And then this other output is our deletes and our older data set. This other feature merger is merging with our master station IDs. So we are reading in all of our stations, and this is identifying the exact station IDs that need to be updated. So then we have this output, and this is going to be our new inserts for our AGOL feature service. I want to point out these two lines. So this output was our inserts, this output was our deletes, and going up to this process, we have our feature writer, and this is being written, our inserts and deletes are being written to an Excel sheet. And once that Excel sheet is completed, we have an email automatically being sent to our environmental science department managers, notifying them that we updated our AGOL dashboard. And so I'm going to pull up that email, and it's just very simple water quality bacteria dashboard changes, and we're able to attach this Excel sheet to it as well. And then I'm going to pull up our Excel sheet. The cool thing about FME is you can separate your data into sheets. So we have our inserts on this sheet, and then our deletes on this other sheet. And this was a pretty cool process that we weren't doing before. We weren't capturing our data in an Excel sheet, nor sending our managers an email automatically. So that was definitely a pro to using this FME automation. All right, moving forward, we have these two transformers. In FME, you need to tell it that, okay, hey, we have this new data set and we need to insert it into our feature service. Or this data set is old and we need to delete it. So following this inserts line, we are assigning the URL to the most recent station ID. As Sarah pointed out in our bacteria dashboard, how we have our pop-up, and in that pop-up we have a link to our website that gives us graphs on the rainfall data. So in this process, we are merging the 7 station IDs that have that information. So we have our 70 station IDs from an Excel sheet. You can see it over here on the left. And we are using this feature merger again, and it is merging the URL information with the new data set. And then finally, we have our AGOL writer, and all this new updated data is being written to the feature service that is represented or reflected in our dashboard. And then going back to our deletes, this is our old data. We are using this writer to delete our data, our old data set. And then also to keep in mind, we do have a backup of it in case we need to restore it for whatever reason. And so that's our workflow. And once we finished this, we published it to our FME server and put it on a schedule to run once a month. So I'm just going to go back real quick to our presentation and show a couple of pros that we are that we have gotten out of using FME. So I think before we were using this automation, it took Sara about 2 days from start to finish. So definitely eliminating these time-consuming tasks. We're eliminating any errors by doing this manually, capturing data in our Excel sheet, also sending an email to our managers, notifying them. No longer using ArcGIS or ArcMap, and we have migrated to ArcPro. And we are also, I wanted to point out that where there's a will, there's a way, and FME has helped us find a way to automatically make these updates. And lastly, this is automatically happening in our sleep. So thank y'all for tuning in. I hope y'all learned something, and thank you.
Thank you to all of our other presenters out there. Absolutely phenomenal job, everybody. And if we really kind of had to think about, what our conversation has been about today, it's really been about how can we best share information or data across our organization. So continuing this theme, that's what I want to talk about with my presentation. How can we share information, whether it's like those dashboards that we've been seeing, throughout all of our presentations so far today, or maybe how can we start to mix a little bit of analytics in there. So I'm real excited to take the opportunity and work with this, and we'll even do a little bit of off-roading and build a dashboard on the fly here. So for some of you that were asking questions, I think it was after Blake's presentation, maybe again we'll get to learn some of those tips and tricks with working with dashboards. So we'll focus on dashboards first and then move into the other app that we asked you about, ArcGIS Insights. So for those of you that might not be familiar with the dashboard, what exactly is it? Well, generally speaking, these are map-centric web applications that have these things called elements or little widgets around the outside that are really meant to draw, some viewer's attention to something that you want to lead them towards, some data point, some data feed that you want them to be able to take a look into. Now, I did say map-centric there at the beginning, but it was actually Blake who earlier today proved me wrong that you don't actually have to have a map in your dashboard. It's possible to build them without maps. So that's some kind of a little trick unto itself to think about, that dashboards don't always have to have maps in them. You can just pull on those layers that you have within your enterprise or online environment. The other thing about dashboards is that they're meant to be this, really quick and intuitive means of looking up data. The dashboard that we saw from the San Antonio River Authority, or the dashboards that we saw from BJWSA, that was just, you open it up, you take a look at what you need to look at, and you move on with your day, which is, really great if you're a manager who just wants to get a quick overview of, how are we doing with inspections this month, or water quality like we saw. So when you have all that information, like everything we saw in the FME presentation, that dashboard just takes it and just shrinks it down into kind of this one-stop shop application where you check it out, you see what you need to see, and you're able to, move on with the rest of your day knowing that you have that information available to you in your back pocket. And what I like most about dashboards is that you can make them look really clean and sharp without having to write a single line of code, and they're not that difficult to make. And I'm not a real big coding guy, so I'll tell you, any day that I don't have to code is a good day. So what can we do with dashboards? Well, maybe here's kind of an example coming directly from a water utility, taking a look at something like hydrant flushing or hydrant inspection. As a GIS professional, we might take a look at a map like this, and okay, we've got a good symbology, blue versus gray, those that have or have not been flushed. But for us, all those tools along the top and on the side, those are great. But we don't want to share that, necessarily with our managers or supervisors. It's not their job to know how to fly ArcGIS online. They just want to be able to look at this map, get the information, and move on. Now, we can use something like this to configure a dashboard, but this isn't what we're going to share out. Instead, we might share out something that looks a little bit more like this. We still have that map-centric approach, which hydrants have or haven't been inspected or flushed. They've been flushed on the west side of the town, not east. But then I have those elements, as you can see on the left-hand side, that provide that quick snapshot overview that as a manager, I can come in the morning or at the end of the day and see where we stand in terms of, what's the total amount of water that's been flushed that's coming in from one of our field apps, Survey 123 or Collector or Quick Capture, or just have a general overview of what's our progress. How many hydrants have been flushed? How many haven't? How are we doing? That very similar gauge that, Krista's been harassing me about all morning, about, seeing, how many of those surveys were submitted. So very practical ways that we can begin to, digest, large data sets and present them in a way that's easily understandable. Or maybe if we're in more of the stormwater sector, we can do something very similar for outfall inspections or storm drain catch basin inspections. But then also maybe if someone's filling out a survey that has a question about, is this an illicit discharge, yes or no, and allow us to, be able to count those up very quickly. So we have these numbers that are, that provide this great overview of what's taking place across, our system or across our utility. And of course, I wouldn't want to leave out our friends in sewer as well. So maybe we want to pull in information about, CCTV inspections. How many mains have or haven't been inspected? What's the total count of the different number of defects that we're seeing within our pipes? And then, of course, we haven't left the whole realm of what GIS is. It's still that interactive map that if you do want to go click on a hydrant, or in this case, a pipe defect, and learn more about it, we can still get that pop-up with the attributes, with the photo, with the built-in bar graphs or pie charts. That information, we can still visualize that as well. So everything that we know and love about web maps are present, but these elements just add a whole nother level of dynamic interaction that's possible. Maybe it's pulling on real-time data. If you have the SCADA data is most common, something like tank levels. You want that quick dashboard you pull up to see how your tanks or how your pumps are doing. We can pull on that and have that visible here as well. So where across the system are our tanks full, where are they, maybe getting a little low, or where do we need to have concern? Just a real quick dashboard like this, open it up, what's the situation, and be able to move on with the rest of the day. And then something like work orders as well. Another great way that we can have, a quick overview of our assets, like we see in the upper left-hand corner. But then maybe starting to pull in information from work orders. That might be possible as well. And having the ability to click on a work order in that list there, you see under the big number 30, and it'll automatically take us to the map. But the one thing that makes GIS so much more powerful than just a map is the ability to have even like analytics on the fly built into it as well. So for this main leak that we're looking at, on the fly, it's even doing a calculation to tell us which field crews are closest to it within 5 miles. Jonas is a little over 1 mile away. Mike is just shy of 3 miles away. So we're still able to pull on some of those pretty simplistic distance analyses within the map, which then gets pulled into the dashboard as well. So much of what GIS is, whether it's interacting with our data, doing little mini analyses, or just viewing our data, it's all built into these dashboards that we're able to work with. So really great way that we get an overview of things that are generally very data rich and maybe almost sometimes too complex. Dashboards help us boil it down to what we need to see. So let's actually go ahead. Let's off-road here for a little bit and actually see what it might look like to build out a dashboard. And for my little example here today, what we'll do is we'll take a look at what it might look like to build a dashboard of just kind of a quick asset overview at a utility. So here I am, I'm in ArcGIS Online. This could be ArcGIS Enterprise as well. And I've just built out a very simple web map. I've symbolized my layers. I've even configured my pop-up so it's, pretty neat and clean, such as this, 8-inch ductile iron pipe. But once my map is all cleaned up and ready to go, I can turn it into a dashboard because it's the dashboard that's going to consume my map. So I can share this out as a web app and choose to share it as a dashboard from the dashboard tab. And so I'll just quickly, give this a DB at the end for dashboard, click done, and it's going to start off by giving me just this skeleton of an app that I can then begin to go through and configure. So there's my map. If I go ahead and click on it, we can see my stylized pop-ups and everything comes through for me. But up here at the top, this is where I can add in all those different elements, those little widgets we've been seeing around the outside today. And I don't have enough time, unfortunately, to go through all of them, so I'll kind of touch on the ones that I personally like most. So we'll start off with a simple one here, a header up at the top. And what we'll see for all of our elements is we configure them on the left, and on the right-hand side is where we get a quick preview of what it might look like. So I might just simply call this asset overview, and press done. And now we can see I have a little header across the top. And as for some of these elements that I think are most useful, we'll start with the indicator. And the indicator element is really just kind of this big in-your-face number that pulls off of one of the layers that you have in your map. Or I could pull from a layer that isn't even in the map, kind of like what Blake did in the first presentation. But anyways, I'm going to start off by taking a look at the fire hydrants here. So by default, it's just telling me the number of features that I have within my layer here. So I have 1,400 fire hydrants. And I can go through the tabs here to help me configure it. And I could use something like this little word processor to give this a name. So we'll just call this hydrants. And we can stylize it as necessary. to give it, the look and feel that we want. So something nice and simple like that. And then I have the ability to, take this, I can resize it, or I can take it and dock it elsewhere within my dashboard as necessary, but I'll keep it on the left-hand side over here. Now it's great that I know that I have 1,400 fire hydrants, but I want to know how many fire hydrants I have currently within my map view, my map extent. Well, that's where map actions come into play. And I can have the different elements within my dashboard kind of communicate or convey information back and forth between each other. So I can go into my map and have it perform an action against my indicator. So for any element that I add, I can configure it by hovering on the little blue bar, going into the gear, and we're always going to see this actions option. And so as I change my map extent, I want it to change what's visible within my indicator. So as I pan around, we can see that this is going to update to tell me how many hydrants are currently within my view. But notice I don't have that number of the total number of hydrants anymore. So I'll go ahead and I'll go back into configure this, and I'll throw in a reference type down at the bottom, which is just a raw count of the number of my features. So now I get the best of both worlds, total number of hydrants, as well as the number currently on the screen. But let's say I wanted to know a little bit more about those 20 fire hydrants that are currently on my screen. Well, that's where we can pull in another type of element, the list element, probably like my second favorite here. And again, we can point this at a layer that exists in our map or elsewhere within our organization. And all it does is it gives me an entry for each one of my different features and some attribute information about it. So again, I can configure it to tell me what I want this to say. So we'll put in some static text for asset ID, and then I'll pull on my dynamic attribute value for the asset ID. And now I can see that my little preview there on the right-hand side is updating. And maybe I'll also can add in the manufacturer information as well, just to build this out a little bit more. And so as a result, we can now see for each one of those entries, my 1,400 fire hydrants, boom, 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 I'm able to get a quick bit of information about them. Now here's where it also becomes powerful yet again. We saw a map action that was filtering the number of, the number that we saw in that indicator element. Well, I can also have my list element talk to the map, that if I click on a particular, entry here in my list, it's going to automatically take me to that hydrant on the map, make it flash, and have the pop-up appear. And again, that's all done through these actions. So I'll have it flash the fire hydrant in my map, and I'll have it pan to that hydrant in my map, and I'll have it show the pop-up within the map as well. So now I have two elements here, and admittedly, this isn't very pretty at the moment, but here's maybe one of my first tips and tricks that I'm a huge fan of. I'm going to drag this element below my indicator here, but I'm going to press and hold the shift button, and notice it changes from blue to green, which actually allows me to group these two elements together. But notice it's still something's kind of wrong here. I got 20 hydrants here, but it's not telling me about the hydrants that are actually on the map. So again, I can have my map also then filter which hydrants are going to be visible within that list. So now what I have is 22 hydrants, and those 22 hydrants are now listed down below for me. So if I actually click on this, we'll see it's going to take me to that hydrant, kind of make it flash in purple for me, and then pull up my element, including the attributes and the picture, like what we saw before. So again, this nice way that we can go ahead and we can start to, pull on the data that we have in the dashboard, bring it all together. And then what I want to do is maybe also, one other quick thing to do here is pull in an indicator element of my mains. Maybe I want to get a quick overview of the amount of distribution mains that I have in my system. Right here, it's just telling me the number of features. Well, I don't really care that I have 4,000 pipe features. I want to know the total length of mains within my system. So instead of just counting the total number of features, I'm going to have it automatically sum up for me the length of my mains. Now, this is currently in meters, which is not very helpful. So I can actually add a value conversion to this to convert it from meters to miles. And we'll go ahead and say that, miles of mains in our system. And I can press done. And then one last thing here to do to maybe show like the different types of mains that we have is I'll throw in a quick serial chart or bar graphs or line graphs of my different mains by their materials. So again, I can point this at my distribution main layer, and pull on my asset type, which is whether it's ductile iron, PVC, cast iron, or unknown. And then again, have it count for me the length of main that I have of each type of material. And as always, I could work my way through the different tabs here to take this and reconfigure it and give it that look or feel that I'm interested in. Maybe change the colors or something like that. And always giving our our different elements here some titles so people actually know what exactly it is they're looking at. And again, actions make these more interactive, that when someone clicks on the ductile iron main, they're only going to see the ductile iron pipes that are present on the map. So again, I'm going to take this and I'm going to group it below the miles of mains that I have here. And then I like maps personally, hence the reason why I do GIS. And so I like to keep this as map centric as possible. So what I'll do then is I'm actually going to drag this whole stack and place it on top of the hydrants here. So now what I have is 2 tabs. I can name this first tab be hydrants, and I can make my second tab here be mains. And now I have this quick overview of my assets across my system that I can quickly come in here, learn more about these different features that we see across our utility, or the mains here, determine where are my ductile iron mains or where are my PVC mains across this utility. So it's this really great way we can now start to interact with and filter our data as necessary. And then I'll go ahead and save this. One little tip and trick also in here is if you get rid of the question mark mode equals edit at the top, it takes the dashboard out of your editor mode. Now here's the thing, we can make a great dashboard like this, and maybe we make a great dashboard that tells us about that hydrant flushing progress and another dashboard about hydrant inspection. But what becomes a problem then is, a dashboard's so useful, but the issue becomes, well, now we have, 5, 6, 10, half a dozen dashboards. Now we have like all these hyperlinks, which one do we go to? So my last little trick here to show you what dashboards is embedding dashboards inside of dashboards. So that way you really only have to go to one dashboard to get the information about all of them. So here I have my 3 individual dashboards as I've shown you. But if I make a 4th dashboard, what I can do is I can use the embedded content element. And this really just allows me to embed a website within a dashboard. So maybe something even like, a weather website if you want to know the weather in the area. But in my case here, what I'm going to do is I'm going to grab the URL of my 3 individual dashboards. So there's our first one. I'll grab the second one for hydrant flushing. Pop that in there. Currently not looking very pretty, but we'll get back to that one in a second. And then I'll grab my 3rd URL. Paste it in there. And then I can take these 3 different embedded pieces of content, and if I stack them all on top of each other, now what I've had the ability to do is just make one URL for this dashboard, and within it I have my 3 individual dashboards. So if you like dashboards or your managers like dashboards, but you're starting to get too many of them, start to embed them inside of each other. So one dashboard can contain other dashboards, and they're still going to retain all of that interactivity that we saw before. So that functionality comes with it. A great way to take maybe a whole bunch of links of dashboards and put them all together. Let's go back into our presentation here and keep rolling along. So let's say you want to get started with dashboard. What are some recommendations that I would pass along to you? As with anything we do, a focused idea is a great place to start. Making a dashboard for the sake of a dashboard is cool, but if you really want someone to use it, make sure you have that focused idea, like the asset overview, like the the inspection progress. Those are great ideas. Simple, focused, non-overwhelming. GIS-wise, it's great if you have layers. That's the building blocks of this. And of course a map, but the maps are not necessary, as we've already mentioned a couple times. If you have those attributes that maybe you want to sum up or average or find min or maximums of, you can pull on those as well. That can empower the dashboard further. And in the event that you actually want to build these out, what does it mean for licensing? You need a creator license to build an ArcGIS dashboard and a viewer license or greater to access it. Unless, of course, you share your dashboard publicly, as I believe our friends in San Antonio have done. So if you want to keep it internally, you will need to have that named user license. So that wraps it up for dashboards. A little bit of a marathon there, but let's go ahead and change gears a little bit to ArcGIS Insights. Insights is great because you can still share data and information across an organization. That's, again, been the whole theme of what we've seen today, how we can effectively share this knowledge. But Insights, in some ways takes it up a notch because you're also able to perform analysis. And when I say analysis, I mean empowering everyone throughout your entire organization with these GIS analytics. Something like ArcGIS Pro or, the older ArcMap, phenomenal tools, great tools for GIS professionals. But if you want to start getting GIS, out, amongst the, everyone else at the organization, Insights is a great way to do this, with other data analysts, because you won't need to have, a bachelor's or a master's degree or a certification in GIS and geography. So this can be shared out to everyone across the organization, and it's great because it can allow us to explore and tear through and understand patterns and trends within our data. And it's able to be done with a drag and drop interface, as we'll see. And when you have those final results, of course, being able to take them and share them is the goal. And we can access data from all kinds of different places. Those relational database management systems that you have, if you have data stored in OneDrive, CSVs, Excel tables, ArcGIS Enterprise, and online. All kinds of different ways you can start to pull your data together and begin to hash your way through it. But probably one of my favorite things about Insights is that you start off with a blank template, and as you work your way through it, Insights is automatically recording for you the steps you've taken for easy, duplication of your process, as well as in the event you want to, review the work that maybe you've done or someone else has done. So the fact that it's automatically recording these steps is just, an excellent way to double check work that's been done and rerun these processes in the future. So what are some examples of what this might look like? These are just screenshots, but if I actually had pulled up, the real web pages here, we would see that these are fully interactive. Here's an example of water quality in Ontario, Canada. And, it gives us this quick overview of taking a look at our data in sodium and chloride data. And like I said, it's all interactive, that if I were to click on, a section of this pie chart, all the other cards, as we call them, the other elements across this workbook would update for me. Maybe we want to take a look at field crew assignments. Who's doing the most work? Where are tasks, in our service territory being completed, or where are they still being worked on? And start to pull on other bits and pieces of information to understand those trends and patterns. And something like this is actually pulling on the data that's coming right in from ArcGIS Workforce, one of our mobile applications, to allow us to understand who's maybe being overburdened with work, or what priority of tasks are being given to whom. Or we want to better understand, your collection network or your distribution network. Again, being able to click on, particular bars in the bar graph or the chords on the chord diagram, and having it just reflect, across the entire workbook what it is you've clicked on. That's going to be possible here with Insights as well. And then there's this example, which I think just it's Insights, and maybe it just belongs in a museum rather than on my PowerPoint presentation here. But this is taking a look at water quality as well within a watershed in Canada. And it's just this phenomenal way of taking a look at data and flow, and something like this heat chart down here in the lower left-hand corner that compares years by month and how much flow they've had. Being able to see that there's that more water in the spring versus more drier in the summer here. Just really great ways that, if you tried to visualize this or look at this another way, it might take you, 10, 15, 20 minutes to dig through and draw a conclusion. This just visualizes it so quickly. And then again, being able to take this and share it out across an entire organization. So let's go ahead and take a look at a simpler example of how we can do some data discovery and patterns working with ArcGIS Insights. So I'll kind of pick on one of my favorite topics here, which is looking into main breaks and understanding maybe why these main breaks have occurred. So in my case here, I just have two simple layers. I've got a layer of my mains and its attributes, and I got a layer for my main breaks and its attributes, and I want to understand, hey, what are the characteristics of these mains that happen to be breaking? So I can drag and drop main breaks on here, and all kinds of different ways that I can take this and visualize it. But we'll start off by quickly throwing it on a map and drag and drop the mains layer in here as well. And if I wanted to maybe revisualize my main break as something like a heat map, and change my base map to be dark gray so we get a little more contrast here. All right, great. I've got my mains, I've got my main breaks. Tell me more about the mains that are breaking. Well, this is where GIS and insights really comes through, the ability to do spatial analytics within insights. So, we can make the bar graphs and the pie charts and all that stuff. We'll take a look at that in a second. But it's the spatial component that still makes ArcGIS Insights so incredibly unique and powerful. Down here, I have an action button, which allows me to perform my spatial analyses. As a GIS professional, generally speaking, I know what these different buttons mean. But if I'm that non-GIS professional, I can use the Find Answers button here to help guide me towards the tool that maybe I would need to solve this question or this problem. So yeah, I want to know what mains are nearby my main breaks. So taking kind of our GIS jargon and maybe putting it into a bit more of, more of like, I don't know, the vernacular, maybe that's the wrong word, more common language that other people can understand. And then it helps reduce the number of tools. And so, I want to find the nearest main break to my main segments. And we'll go ahead and give this a second to run. But what I'll end up with then is a new layer that is going to tell me the characteristics of the main nearest the actual break itself. So I'm just going to quickly rebuild our map here that we're looking at. Again, quick drag and drop to get my mains in here and my main breaks that now have additional information. And again, just quickly resize this, because visualization still remains, very powerful when we're working in ArcGIS Insights. Okay, there we go. Same map as before, but now my main breaks have a little bit more information about them, been appended to them. So maybe I want to look up the installation year of those different mains that have broken. So I can get a quick, bar graph here. Okay, those are the years of the mains that have, had these breaks occur on them. Or maybe I want to pull on a quick bar chart of the different materials of my mains that have broken. And lastly, I'll bring in the diameter of my mains that have broken here as well as a bubble chart. So quickly at a glance, looking over this, okay, my mains that have broken have been cast iron, ductile iron, or an unknown material, a whole spread of different diameters. But when I look at my the year that the mains were installed, that's where I get a little bit surprised, actually. That here I would look and say, okay, old pipes break. That makes sense. As it gets older, they deteriorate. But here I'm noticing, like, why are pipes that aren't even 20 years old? Why are they breaking? They're only 19 years old. So this is where the interactivity of my cards really comes into play. That if I go ahead and click on this 2002 here, we'll see that all the other cards across this workbook are going to update for me. That I know that those mains that have broken in 2002 are ductile iron pipes that were 8 and 12 inches in diameter that occurred mostly in the downtown Naperville area. So this provides me that quick overview then if I want to now figure out, okay, we have some money in the budget for capital improvement project, which mains should maybe we take a look into? And maybe we start to figure out where else in the system we have ductile iron pipes that are 8 and 12 inches in diameter. Maybe there's a bad batch or something of that nature. Maybe you've recorded attribute information about who's installed these pipes, whether it was done by people at the utility or outside contractors. All these different factors can now be brought together to help understand what's taking place across the utility, to help guide and drive decisions based upon data, not simply best guessing or sometimes throwing darts at a dartboard. But when I'm done with this, I could actually take this whole page here and I could share it out, much like those screenshots that I showed you earlier. And in fact, we would still have that interactivity, even if we did take it and share it. And then, like I was also mentioning, that favorite part of mine is coming here and with a single click, being able to see the whole entire workflow that's been done. So maybe if Krista had done this analysis, I'd have the ability to take a look at it, review it and say, okay, this is good, or maybe we need to make these changes. But the other thing I like best about it is the ability to rerun the process. So let's say at the end of 2021, we got that new main break data set. I could update the data set in here to be that newer version, click the update button, and this whole process is just going to rerun. I don't have to go through the steps all over again. It's just going to work its way through that this geography, this analysis process for me. So really great ways that we can start to pull in data and start to come up with analyses as well as visualize them in a way that isn't super GIS dense, but still provides a good overview. So let's say you want to get started with ArcGIS Insights because you want to empower more people with GIS, or you want to, start to have this easier way of looking at and sharing at and analyzing data. If you already have a creator user type license, there's an ArcGIS Insights add-on license that can be tacked onto that to give you access to ArcGIS Insights. Or maybe you have those people that, again, they're not going to be those, hardcore GIS analysts, but they still want to have maybe access to do some of this lightweight analyses and visualization. Well, there's what's known as a standalone Insights Analyst user type license as well that you can give them. They won't have that creator license or that field worker user type that you might be familiar with, but it'll just give them access to ArcGIS Insights and the ability to share Insights pages across the entire organization for others to take a look at. And as I mentioned before, if you want to be able to just simply view the final product that someone else has made, a viewer license or greater would be necessary, unless of course your workbook was shared out publicly. So in terms of just simply viewing an Insights page, it's identical to what we saw with ArcGIS dashboards. So with that, that concludes my presentation. Thank you everybody for sticking it out. It's been a great day seeing everyone else's presentations, and I hope mine lived up to the hype that was shown by everyone else's. And I hope everyone was able to maybe learn something new about dashboards or understand something we can do with Insights. And with that, again, thank you, and I'll turn it back over to Krista.